Hey guys, welcome back. Today, let's master Codeforces 2183B, yet another MEX problem. So we're given an array linked in and an integer k. Let f of LR be the value of the MEX from AL to AR. You want to perform the operation n minus k plus 1 times, and the operation is let the current length of sequence be absolute value of a. You need to find an interval LR of length k such that the max from I equals 1 to absolute value of a minus k plus 1, f of I plus k minus 1 is equal to f LR. Now what does that mean? In other words, you need to select a window of size k such that among all windows of size k, the window you selected has the maximum MEX. If multiple LR exist, you may select any. Then you must select any integer I such that L is less than or like I is between LR, right? And delete AI from A. All right. So that's your new sequence, blah, blah, blah. Now, first things first, let's go over what MEX is. MEX is just the first missing number in an array of elements. So, for example, if we had 0, 1, 2, 4, our MEX would equal to 3 because that's the first missing element. Now, if we had 1, 2, 3, 4, our MEX would be 0 because that's our first missing element, right? Alrighty. Now, there's a few things to notice about this question that makes this operation kind of arbitrary, because if you just try to simulate this operation, it's going to be way too slow, right? There's a lot of moving parts. You need to select a window. You need to then select an integer between that window. Which one do you select, and delete it. And you do this n minus k plus 1 times, right? So the first thing to notice, or rather they kind of tell you, is that after you do n minus k plus 1 operations on your array, you'll be left with an array of length k minus 1. So what does this mean? This tells us that our MEX can never be a number greater than k minus 1, because we simply will just not have enough numbers to create the MEX of that number. So what I mean by that is, if we have, like, say our last number was 5 after doing all the operations, if we had every possible number to make 5, like 0, 1, 2, 3, 4, then yeah, we could make 5. But we would never be able to make something like 7, because we're always going to be missing 6. And this is our k minus 1 array. Like, if we are able to come up with a 6, then we would have k elements, right? And say we do have a 6, but we don't have 3, then our MEX would just be the first missing number, which is 3, right? So that's the first thing to notice. The next thing to notice is that, what should we remove from the array, right? Like, say we're selecting this window, what should we try to remove? Well, first things first, duplicates. And this is because if we have an array with like a ton of duplicates, 2, 2, 3, 3, 3, removing a duplicate won't affect the MEX at all. Like, we can remove a 2, our MEX would still be 4. We can remove 2 3s, our MEX would still be 4. We can remove a 0, 2 1s, our MEX would still be 4. Because we still have the building blocks of 0, 1, 2, and 3, right? Now the second thing to remove is the largest number. This is because if we had 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, if we remove 5, we can still build 5 as our MEX because we have all the previous components, right? But if we remove 2, then our MEX would be at 2, because we don't have 2 to build a MEX of 3 or a MEX of 4 or anything higher, really. Now, with these 2 observations, we kind of realize that our answer will just be the first missing element in our array, simply because of the logic that, like I said, if we're missing 2, we won't have the components to build anything greater. And when we're selecting, we can always select a duplicate, or we shift our window to select a higher number than like the components that we need to build what we can so far. So if there's no missing elements, however, there's one like extra case, then we can simply set our MEX to be equal to k minus 1, because then that means we have all the components necessary to make the length of our array. Now let's start coding this up. First things first, let's take up in some input. T equals int input. For blank in range t, we take in k, which is our length of the array and the length of the window. Map int input split. And then we take in our array a equals list map int input split. And all right, let's define our MEX. So at first, let's set our MEX at -1. Then let's create a count array for how many times each number shows up in our given array. So count is equal to 0 times n plus 1. So we're just setting it like the indexes will be the value of a, and the values of count will be how many times that value of a shows up. So for I in a, count I plus equals 1. Next, we just have to iterate from I to our limit, which is k minus 1, and check if the value is 0 in count. That means it's just missing completely, right? So if not count I, then we should just set our MEX to be I and break. And then at the end, we add a check for if there's no missing values. So if there's no missing values, MEX will be -1 the whole time. It'll go through this loop and nothing will change. And we would simply just set MEX to k minus 1. And then at the end, let's just print out our MEX. There we go. That's the full solution. And let's see my submission to this problem. Yep, pretty much the same. Run it and it works. And yeah. If y'all enjoyed this video, be sure to like and subscribe. And I'll see y'all guys next time. Bye.